Hello, everyone. Now, we want to introduce what is calculus and what are we going to be doing in this unit. So, when we're looking at calculus, the biggest three topics are limits, derivatives, and integrals. And in order to be able to do derivatives and integrals, we need to be able to understand what a limit is. So that's what we're going to be looking at in this video. What is a limit and what does it mean to have instantaneous change? Now, instantaneous change means that it's happening at an instant. So if I said, what is the limit at this point, right? What is the limit at 4, for instance, at x is equal to 4? Now, if you were to look at this, you're going to say, well, I know that, what is, if I'm asking you, what is the change here? Well, we understood change as average rate of change, right? You've looked at this before. You've looking at average change. So if I asked you, what is the average change from point 2 and 3, and let's say 5 and 2, then you would have done change of change of y all over change of x, right? You would have looked at the slope or the average rate of change, which is, I just look at the difference between that. So I would have done, y values, so 2 minus 3 all over, and if I'm treating this as kind of 0.2 and this is 0.1, right? So I take the 2 minus 3 all over 5 minus 2, and then I'm looking at average rate of change, and that's just going to be -1 all over 3. So I would say that the average rate of change between those 2 points is indeed represented by this line with the slope of -1 over 3. So basically what I'm saying is that if I were to consider what is the average rate of change in this space between those 2 points, so kind of this area over here, then I'm really just talking about, you know, an entire interval. But what if I told you what is the instantaneous rate of change? So then I'm asking you at this instance of x is equal to 4, what is the slope, right? Now, that is a little bit more difficult, but that's where limits come in. So limits tell us that, listen, we can look at a specific point and narrow it down. So what we're going to do is really just say, listen, I'm going to look at this point x is equal to 4, and I'm going to create an interval that is very, very small in that space. So kind of like, I'll say, all right, well, what if I took a very small interval between these 2 points? So let's say over here, let's say I ask you, what is the rate of change at x is equal to 4? Then kind of I would look at this interval over here, and I continue to make it smaller and smaller and smaller until I'm almost looking at that instant, right? So this over here looks like I'm looking at 2 instances. However, I'm trying to make them smaller and smaller. That's what limit is trying to do. So it's saying, okay, I'm going to still look at average rate of change, but I'm going to look at it in a small interval, in an interval that is getting small. So if I were to say, you know what, look at this over here. Let's say we're calling this instant, between the 2 instances. Let's say over here, this is a and this is x. And I'm asking you, what is the what is the instantaneous rate of change? So instead of at 4, we'll come back to that. But instead of at 4, I'm asking you at a, at random point a. Then what you're really looking at is this change over here in this interval, and you're trying to make that interval smaller. So instead of this x, we're trying to get really close to a. So if this is my a value, then I'm trying to get a point that's very, very close to it on the curve as well. So then what I'm going to say is I'm going to say, listen, well, if I did that, then I'd say f of x, right? I'm just doing change of y all over change of x, right? So that's the same as doing f at x. So the point that I'm going to choose minus f at a, the point that I'm asked, all over x minus a, right? That's the same thing that we've been doing. Now, over here, if we're talking about the distance that we're trying to make smaller, I'm actually going to label that as H. We're going to label it as H because we're going to say H. We're going to say H is the difference, the difference between the point, I'm going to say of interest, I just wrote that twice, All right, let's change that. Point of interest and narrowing interval. Endpoint. So that X that we've chosen, and we're narrowing, right? So this is H, and then if I'm making it smaller, then that's my new H, and so on. So then over here, this is one way of representing it, but let's say I wanted to represent it in terms of H getting smaller. Then I would actually write this as f of X plus H, right? So it's whatever this X is, this, whatever the point of interest is, plus the distance H. So it would be this new point, right? So that's why it would be this new point minus f of X all over that difference. So X plus H minus X. Well, we can see that that's really just H, right? Because X and X cancel out. So then I can represent it like this. So then over here, this is two ways of looking at limits of looking at an average rate of change in a very small interval. Now, what limit says is that if I were to write over here outside of this, if I were to write limit as X approaches A, well, what does that mean? That means that the X value is getting very close to A. Now, I can't take it, I can't make X equal to A, right? Because if I were to make X equal to A, then over here in my denominator, I would be looking at A minus A, that's 0, right? So that would make it undefined. So I know that I can't look at X equal to A, but I know that I can get very close to A to the point where over here, I'm very close to my point of interest. And then I'm basically making my average rate of change a very, very small interval. And then I'm looking at what happens if X approaches A. So if A was 3, then I can make X, for instance, 2.9999. So it's just approaching A. That's what limit is saying. It's saying it's approaching A. So then over here, that's one way of representing it. And if I were to use the H method, then H is this interval, right? I want the interval to be very small. So if I'm looking at this interval over here, then I need this interval to be as small as possible, right? Now I know I can't be an interval of 0 because I know I'm looking at an interval. So I need two points, but I need them to be very close. So I need the interval length H to be approaching 0. Okay. So these are two different ways of looking at limits, and limits, remember, are basically a way to find what is the change at an instant. What is the instantaneous change? So what is the change at a specific point? Okay. All right, everyone. I hope that helped, and I hope I'll see you in the next video. Bye.